Figure out what is on the quiz. Here we are. All right. Bicycle travelist 11 miles in 2 hours and 45 minutes. What's her average velocity during the entire 2 3/4 hour time interval? What would you do? (11 divided by 2.75). Somebody help me out there. What? Wow. That's awesome. That's 4. All right. If we use radian mode for this, I don't know why it has to be in radian mode, but hey, whatever. If we use radian mode for this, and we graph this function, which one of those 4 graphs is it? Well, obviously it has to be A, B, or C, because it can't be D because it's a positive x cubed. And it's plus 3, so I would say it's C. And then at f of 1, is the first derivative positive, negative, or 0? At the first derivative at the x value of 1. It's negative because the graph is going down and the first derivative is the slope of the function. Okay? So slope at an x value of 1 is negative because the graph is going down. Okay? You taking calculus next year, Mr. Comas? All right. You're setting yourself up good. All right. Which graph is f of x equals negative 2x squared on that graph? Well, we know it can't be B or D because it's negative. So it has to be A or C. Now, that's the graph of the tangent line. So we'll find that out in a little bit. All right. So we have to find the graph of the function at this point. Okay? So let's find that. So we go f of x plus h minus f of x all over h, right? You know, there's an easier way to do this. If our function is negative 2x squared, we can use what is called the power rule and skip over this darn thing. I just made you learn it the hard way. The power rule says take this times this and lower the power by 1. So the first derivative at this point would be negative 4x. Oh, Mr. Bierschbach, we all hate you right now for not showing us that at the start. Well, that's calculus, people. We make you do it the hard way, and then we show you the easy way so you can understand the joy of knowing it the easy way. All right. So if we stick our 2 in there, our slope at that point is negative 8. Okay? And then find the equation of the tangent line at that point. Well, first of all, where is the point at? At what point am I at on that function? At 2 what? What is the ordered pair of my point? 2 what? Well, to find the y value of the point, I would stick my 2 into the function. 2 squared is 4 times negative 2 is negative 8. Now, is your y value always going to be the same as your slope? And the answer is no. But in this case, it is. Okay? So now, if I want to find the equation of the line, I use point-slope form. What's point-slope form? Well, it's y minus y1 equals m times x minus x1. So y minus a negative 8 equals my slope of 2 times x minus 2. Oop. My slope is negative 8. I was going to say something went wrong there. Minus a negative is plus a positive, so y plus 8 equals negative 8x plus 16. And then subtract 8. So y equals negative 8x plus 8. That's my tangent line. Which tangent line would be y equals negative 8x plus 8 with the proper graph? It would be C. Okay, so that problem is a little more work, but, oh, look, the easy way of doing this. So let's say you had a function f of x equals 3x squared minus 4 or plus 4x minus 2. What's the first derivative of that function? 2 times 3 is 6x, and then lower the power by 1, so it's just 6x, plus 4, because 1 times 4 is 4, and lower the power by 1, x to the 0 is 1, anything to the 0 power is 1, and then 2 doesn't have a variable, so it disappears. That's how you do first derivatives by the power rule. You'll get a lot more power rule next year in AP Calc. Those of you who take AP Calc will use it all the time. But we don't have to, I don't want to scare you away from taking AP Calc by thinking you have to do this the whole entire year. That would suck. And I don't want AP Calculus to suck. Okay, so what's the derivative of this function? Because does the 8 matter? No, that disappears. So you have negative x squared. What's the first derivative of negative x squared? Negative 2x. Because the 2 goes out front, and the power goes down by 1. So then you stick 8 in there. The first derivative at 8 is negative 16. Catching all this, Carson? This is like easy peasy now, right? Absolutely. So what's the first derivative of this function? 6x. Isn't Mr. Bierschbach so nice for teaching you that at the last minute? And stick a negative 3 in there, and you get negative 18. What's the first derivative of this function? Negative 4x plus 7. Okay, derivatives. Easy peasy, lemon squeezy. Okay. Yeah, it took a long time to do it the other way. Mr. Bierschbach just saved you a lot of time. Okay. Now, this is a problem from maybe 4th grade. I decided to throw it on your last test. A train travels at 55 miles per hour for 4 hours. How far does it travel? 220 miles. All right. Got to throw that on there. Just be nice. All right. Then we got this. The region under the curve. Next year in calculus, I'll teach you a shortcut to this, but not today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34 full squares. So through half of it, because this is symmetrical, right? So I only have to do half and then just multiply by 2. So this can be number 35, which takes up this little section. This can be 36, which takes up this little section. This can be 37, which takes up this little section. And then we'll save that one for a little bit. This can be 38, which takes up this little section. This can be 39, which takes up this little section. This can be 40, which takes up this little section. Okay? So between this one and this one, this can be 41. Between this one and this one, this can be like 42. Okay? So 42 times 2 is 84. It might be also 85 because that might be in a half, but let's just go with 84. Let's see what the answer was. One above what you think it is, so it's 85 then. Oh, number 8. 85 it was. Okay, 85 it was. Okay. Because that's like 1.5. All right. Ooh. Let's get this back to where it's supposed to be. There we go. All right. Partitions. How we divide this into 4 subintervals. Each subinterval will be how long? 1/2. So you start at 3 and go to 3.5. And then at 3.5, you go to 4, and so on. So it'd be this one. Okay. You take how far this is, which is 2, divided by the number of subintervals, which is 4. So it's each one is 1/2 long. Okay. You start at 3, and then you go to 3.5. Well, 3.5 isn't listed here. What's 3.5? Well, it's the same as 7/2. Then you start at 7/2, and you go to the next number, which is 8/2, which is 4. Then you start at 4 and go to 9/2. And then you go 9/2 to 5. Yep. All right. 10 minus x squared. The interval from 0 to 10. Well, I might want to grab that on my graphic calculator just to make sure I'm right. But I'm thinking it's this one. Okay. So we have to compute the LRAM of this. Okay. What's the LRAM? It's when you line up the triangle to, or the rectangle to the left side. And when I print these, they just go nuts. So this isn't correct. But there is no triangle here because, or rectangle here, because it's at 0 on the left-hand side. Then the rectangle here is like this. The rectangle here is like this. And the rectangle here is like this. All right. So how do we find the height of the rectangle? Well, the height of the rectangle is when, like if you put in a 0 into this function, the height at 0 is going to give you 0. And then you take it times the width of 2.5 and you still get 0. The height at 2.5 is when you put 2.5 into this function. So 10 times 2.5 is 25 minus 2.5 squared. 2.5 squared is 6.25. So 25 minus 6.25 is like 18.75, right? Anybody checking my math? All right. Nobody can check my math, whatever. Then you stick in a 5. 5 in here gives me 50 minus 25, which is 25, times the width of 2.5, which gives me 62.5. Was I right on this one, Dylan? I messed up my equation. So it's 10 times 2.5 minus 2.5 squared. Yeah. Take that times 2.5. 46.875. And then the height at 7.5 is probably 18.75, right? Times 2.5 is 46.875. If we add these 4 up, which 0, really it's adding 3 of them up, what do we get for an LRAM? 156.25. Okay. Now we're going to do the RRAM. So the RRAM is the right-hand side, so it's going to be like this, and like this, which is going to be the same thing, right? So if it's the same thing, that's going to be 156.28, 25, not 28. So the average is 156.25. Now, they're only the same if they're symmetrical, if they're divided symmetrically, okay? But this problem should be divided symmetrically. All right, integral of this. Compute the area, okay? So we'll figure out how to do integrals next year really, really well, okay? But for us, we're going to do the area way of doing it. So y equals the number here. So what's y equals 2 look like as a graph? Horizontal line. And we're going from 0 to 3. From 0 to 3. So it's 3 wide, 2 high. It's a rectangle. Area is 6. Point 1x is a graph that goes up like this. From 2 to 8. Okay? So it's a trapezoid, where the height is the distance from 2 to 8. So the area of a trapezoid is 1/2 the height. From 2 to 8, it's 6. Base 1 is down here. If you stick a 2 into here, you get 0.2. Base 2 is up here. If you stick in an 8, you get 0.8. You add them, you get 1 times half of 6. The area of that trapezoid is 3. Okay, this one, x plus 8 goes up like that. Ooh, we're going from -6 to 8. It's a trapezoid, so we take 1/2 the height. The height is the distance between these two numbers. How far is it between -6 and 8? 14 times the bases. Well, -6 plus 8 is 2. 8 plus 8 is 16. So 7 times 18 is 6, carry the 5, 126. Okay. Here we have the integral . Here we have the integral from 0 to 2 seconds of 32t. So 32t goes like this. It's a triangle from 0 to 2. What's the height at 2? If you stick a 2 in here, 32 times 2 is 64. So the area of a triangle is 1/2 the base times the height. So it's 1/2 of 2 times 64, which is 64. Okay. Limits by substitution. If we stick in a -1, can we do that and get a limit? Absolutely. Carson's going, yep. Everybody else is going, huh? Limit. What's a limit? Stick in the -1. There's nothing that's going to stop you from doing direct substitution here. So it's -1 times -1 minus 1 squared, which is -1 times -2 squared, which is -1 times 4, which is -4. Okay. Anything stopping us from sticking in the 5 there? No. So it's the negative of 5 squared plus 3 times 5 minus 2. So it's -25 plus 15 minus 2, or -10 minus 2, which is -12. If we stick in a -3 here, we get 5 minus a -3 to the 5/3 power, or 8 to the 5/3 power, which is the same as 8 to the 1/3 to the 5th. The cube root of 8 is 2. 2 to the 5th is 32. What's the problem with finding the limit here? The value of the denominator is 0 when you plug in 3, and the value of the numerator is 0. So it's indeterminate. Because if you stick in as negative 3 here, you get 9 minus 33 plus 24. When you have indeterminate form, what that means is you can probably factor it. And next year, you will use L'Hopital's rule to help us out too, when it's in indeterminate form. But we won't worry about L'Hopital this year. Okay, so we have x and x. Signs are the same. They're both positive, plus and plus. Factors of 24 are 8 and 3. So it's x plus 3, x minus 3 here. Well, cancel. And now life is good. Because now we can use direct substitution. Put in negative 3 here, we get 5. Put in negative 3 here, we get negative 6. So it's negative 5, 6. Boom. We are able to find the limit, even though it's 0 over 0. Okay. What's the limit as we come from the left? As we're coming from the left, where do we go to? To the number 2, as we're coming from the left, because we're going like that. As we're coming from the right, where's our limit? 3, because we're coming this way to 3. And so what's the limit as we're coming from the left and right combined? Their limit does not exist. What'd you say? The limit does not exist. Mean Girls. Sorry. I just get excited. All right. Finally, no way. I think we have 21 questions. Limits here. What's the limit as we go towards 4 from the left? 5. Ooh, you guys are good. It is 5. What's the limit of this as we're going towards 4 from the right? It's still 5. So what's the limit at that function? 5, because it's the same coming from the left and the right. They have to be the same to work there. Okay? And the last one, number 21. Ooh, it's a big one. It's easy. It is so easy. Chloe Schneider, welcome back.
I've been here all day.
Okay, so as we're going towards negative 3 from the right, Chloe, should I take away your phone?
No, I'm not.
As we're going towards negative 3 from the right, towards negative 3 from the right, looks like it's 9. That's true. As we're going towards 0 from the left, it's definitely not 4, so that's false. As we're going towards 0 from the left and right, is the same. That's true. As we go towards 0, it exists. That's true, because it's going to be 0. It is 0, so that's true. As we go towards 3, it's 9. No, that is false. Because as we go towards 3 from the left, it goes up there. As we go towards 3 from the right, we're down here. So it goes towards 9 and it goes towards 0. So if it has 2 different limits, now look what I did. I screwed that up. Oh well. It is false. And then the last one, as we go towards 6 from the left, and I keep screwing this up because I'm too zoomed in. As we go towards 6 from the left, what is it?